Okay guys, today we were talking about inverse trig functions. So like when we have the sine of an angle, like the one we used was sine of pi over 6 equals 1/2. What we want is to have an inverse function that would take 1/2 and assign it to an angle. And of course this is going to turn out to be pi over 6. But the thing that we talked about mostly is that these angles that are answers have to be within a certain range of values. You're not going to take any angle that has a sine of 1/2. You'd have to have an angle that's between negative pi over 2 and pi over 2 for sine. So inverse sine kind of uses the right side of the circle from negative pi over 2 all the way up to pi over 2. And for what it's worth, inverse tangent uses those same angles from negative pi over 2 to pi over 2. But then for cosine, you're going to use the top part of the circle from 0 to pi. So inverse cosine is always going to result in an angle that's on the top of the circle. Inverse sine will use an angle that's on the right side of the circle. And inverse tangent will also use one that's on the right side of the circle. So this is where we left off today, and we were getting to the point where I was trying to get to the point where we could take an expression like this, inverse cosine of negative root 3 over 2, and turn that into an English sentence that says the angle between 0 and pi, whose cosine is negative root 3 over 2. And we were just about finished that. We realized that if our cosine is negative, we're going to be over on the left side, and somebody figured out that that angle in there was going to be pi over 6. The reference angle would be pi over 6, which would mean the actual angle that we've gone to, this one that gets us there, would be 5 pi over 6, because it's 5/6 of the way all the way over to pi, which is right there. So the answer to that question is 5 pi over 6. So in looking at this next example here, with this inverse sine here, what I'd like to be able to do is say, can I translate this into a sentence like this? And we have to think about inverse sine and where it gets its angles. And we just talked about that, where inverse sine gets its angles on the right side of the circle, so from, say, negative pi over 2 to pi over 2. So this is the angle between negative pi over 2 and pi over 2, whose sine is root 2 over 2. So we can think about a picture that would look like. And we'd be talking about an angle somewhere over here whose sine is root 2 over 2. Well, it's positive. Okay, so that's going to have to mean that it's going to be up top like this. And you should recognize root 2 over 2 by now. That's going to happen at all the pi over 4s. So that angle in there, the reference angle, is pi over 4. And of course, that's exactly the same as the angle you'd need to get to. So that answer is pi over 4. So we could do these other three examples that same way, basically trying to decide where our angle is going to be. I will tell you, though, that example 3 is a curveball. And the correct answer to example 3 is there is no solution to number 3, and maybe you can think about why. If you try to apply this kind of sentence where it's the angle between negative pi over 2 and pi over 2, whose sine is 2. And I'll just leave that at that and see if you can think about why that has no solution. But example 4 and example 5 be the same way, and hopefully we'll be okay with getting those on your own. Okay, so now I want to see if we can take this a step further and take a look at example 6 here. And we're being asked to find the tangent of the inverse tangent of 5. And if we talk about what we were doing earlier today with something like f inverse of f of x, and if you go back to the note sheet on the first page, I think you'll see that that's supposed to equal x. So if we go f of f inverse of x, is that also going to be equal x? And I think you can see that whatever f inverse does to the function, let's say we were using that example where 3 goes in and becomes a 9. Well, the function would then take that 9 and turn it back into a 3. So although this seems like this answer up here should just be 5, we should maybe just double check and see if it really works, because there are going to be some issues with the domains and ranges of these functions. So I'm going to take a look at this one, and if we said, I've rewritten the example over here, the tangent of the inverse tangent of 5. So this inside part right there, that is the inverse tangent of 5. That means it's an angle. I'm going to put theta there. And it's an angle whose tangent is 5. So that angle right there, if we had a 5 there and a 1 there, this angle would be an angle whose tangent is 5. Now, let's go ahead and say that that angle right there, theta, is an angle whose tangent is 5. So that means we'll be talking about trying to take the tangent of that angle. See, from up here, we're trying to take the tangent of that angle. Well, if I ask anybody, look at this picture, here's theta, what's the tangent of theta? They'd say, well, it's opposite over adjacent, it's 5. So the answer would be 5. So this final answer up here is that this stuff would be equal to, this stuff up here would equal 5. So you inverse tangent 5, and then you tangent it, you're going to get back to what you started with, which is a 5. And so, we can go ahead and put that down as our final answer here is 5. But now if you read my question on this next one, will this always work? That kind of implies that maybe it won't. So maybe on your own, you could go and try to find the sine of 5 pi over 3, get a value for that, and then take the inverse sine of that value and see if you get 5 pi over 3 out. So what you should really do is now, pause the video, see what you get when you get the sine of 5 pi over 3, get a value by that. It should be a fraction, like one of our numbers, like 1/2, root 3 over 2, negative root 3 over 2, negative 1/2, something like that. And once you get that, take the inverse sine of that fraction and find out what angle it gives you. I have a feeling it's not going to be 5 pi over 3. So pause the video and see what happens. Okay, so I've got a picture here that shows us the angle 5 pi over 3, which is going to come around and leave you pi over 3 away from all the way around. In other words, all the way around is 6 pi over 3. So 5 pi over 3 is going to leave you pi over 3 away from the x-axis. Pi over 3 being your reference angle, so the opposite side is going to be root 3, the adjacent side is going to be 1, hypotenuse is going to be 2, and because this root 3 is going down, it's negative root 3. So the sine of 5 pi over 3 is negative root 3 over 2. And now we're being tasked with use the inverse tangent on negative root 3 over 2. Well, if you remember, everything about class was inverse tangent uses angles between negative pi over 2 and pi over 2. So that means I'd be talking about coming down to negative pi over 2 or going up to pi over 2 to try to find the angle that has a sine of negative root 3 over 2. Well, that angle, you can see it right here. That angle we're going to get is going to be negative pi over 3. And you could say, well, couldn't you just call that 5 pi over 3? And yes, you could, but that would not be an angle that's between negative pi over 2 and between negative pi over 2 and pi over 2. So the correct answer to this is negative pi over 3. And you can see it's not the same as what we got started with. So what you can realize from all this is when the inverse is the first function that you're seeing on the inside, and then you use the inverse of that. So for example, if you have an inverse sine on the inside and a sine on the outside, you can trust that the answer is going to be what you think it might be, which is 1/2. But if you have a regular trig function on the inside, like sine, and then its inverse on the outside, you can't assume that the answer is just going to undo what's being done. Because it's kind of a long explanation, but it's because any angle in the world can go in there and get sine, but inverse sine is only going to let out certain angles. So with that in mind, you should be able to tackle problems like example 9, example 10, example 11. But I would suggest that you draw a picture for each one of these when you start to identify what angle we're talking about if we've got the angle whose cosine is 1/2. Because remember, cosine, the inverse cosine, uses angles at the top of the circle. Okay, it goes from 0 to pi. It's going to get its positive cosine values over here on the right and negative cosine values over on the left. So if the cosine's 1/2, it sounds like it's going to be over on the right. And it's going to be a 1 as the adjacent side and a 2 as the hypotenuse. And you should recognize what angle that is and then be able to take the sine of that angle. Now, in this case, that angle is a known angle. That's one of our special angles. But you really wouldn't need to even find out what that angle is, because the first thing that happens after you find out whatever that angle is you're going to take the sine of that angle. So if we call that angle theta in there, right in here, the sine of that angle is just the opposite side, which is this side over here, over the hypotenuse. So the answer is going to be something over 2, but you know what that opposite side is. You know when you have a 1 here and a 2 there that this side is going to be root 3. So we could go ahead and put a root 3 there and put our answer as root 3 over 2. So these problems, example 9, 10, 11, are really nicely handled by just using a triangle, just drawing a triangle that would describe the situation. Okay, and our last trig topic is going to be how are we going to work with inverse trig functions and trig functions when there's kind of like an algebraic expression in here with x's rather than just a numeric expression. And our goal is to express this cosine of the inverse tangent as an algebraic expression. In other words, our answer shouldn't have any trig in it, shouldn't have any cosines or tangents or sines or secants or anything like that in it. And these problems are actually kind of cool. It's like a nice little puzzle. So what I'm going to do is take a look at this first example, which I have shown over here to the right, a cosine of the inverse tangent of x over 3. And we want to kind of break it down. So we're just going to say, all right, this part inside here, we have a phrase for how to describe what that black bracket is asking about. And it's the inverse tangent of x over 3, which we've learned to say the angle between negative pi over 2 and pi over 2, whose tangent is x over 3. Now we're going to assume that x is a positive number for right now for our purposes. So an angle whose tangent is an angle between negative pi over 2 and pi over 2, whose tangent is x over 3. So we're talking about the right side of the circle. So if I were to say x is positive, that means we're going to be in the top, and I'd be drawing a triangle that would look like this. Actually, let me make that a red triangle so it can pop out a little bit more. And it says this angle, whatever it is, I'll just call it theta, has a tangent of x over 3. So that means its opposite side is x, and its adjacent is 3. So what we can do is now take a look at what we're being asked to do, which is take the cosine, rather, of that angle, because we want to take the cosine of the angle whose tangent is x over 3. So we want to get the cosine of this angle. Well, we don't need to find the angle, we just need to find its cosine. So it's the adjacent side over the hypotenuse, and there's the problem. We don't have a hypotenuse. So what we're going to do is come up with an expression for this hypotenuse. And the way we're going to do that is our good old friend Pythag. We're going to do a squared plus b squared equals c squared. So I'm just going to put a question mark here because we don't know what it is, but we do know from Pythag that a squared plus b squared equals c squared. So that in this case it would be 3 squared plus x squared equals our question mark squared. So we could say 9 plus x squared equals question mark squared, but our issue is let's find out what question mark is. So that means we're going to have to take square roots of both sides. So, and we're going to again assume x is positive. We're going to assume we're in the first quadrant, so we can take the positive square root. So we can say question mark is the square root of 9 plus x squared. So that means for this side over here, where we have the question mark, we actually do have an expression for it. It's the square root of 9 plus x squared. So when we come back to our question of can we find the cosine of that angle, can we find the cosine of this angle, we can take the adjacent side over the hypotenuse and express it as 3 over the square root of 9 plus x squared. And if you'll notice, there's an expression that is strictly algebraic. In other words, it doesn't have any sines or cosines or tangents in it, and it would give you exactly the same value as any number you plug in here. So for example, if x was 13, when you plug x equals 13 in here and you find the angle whose tangent is 13 over 3, it'll give you some angle, and then you take the cosine of that angle, you're going to get some fraction. Well, guess what? You get the exact same fraction if you do this. So it's pretty cool that you can use algebra to express a trig identity. So anyway, guys, that's the last of our trig. Next up is calc.